Hey everyone, welcome to another episode of the LlamaIndex webinar series. Today we have a special guest with us, and we're excited to feature OpenDevin. And so OpenDevin is an open source project that is trying to build an open source version of Devin, the autonomous AI software engineer. So it's very exciting because this is actually completely open source, and so therefore the community is actually able to understand what it takes to actually build a fully autonomous coding assistant. Obviously, there's a lot of interest in agents these days, especially around assistants that can autonomously, code, like do tasks for you, and then actually build an entire software project. And so excited to feature Robert, one of the core contributors to OpenDevin, who will be walking us through, it seems like, a few slides as well as a demo. And we'll have a pretty fun discussion on, agents, how to build them, as well as the future and what's coming next. So without further ado, I'll pass it to Robert.
Awesome. Thanks a bunch, Jerry. I'm super excited to be here. And thank you to the LlamaIndex team as a whole for having us. So yeah, like Jerry said, we're building OpenDevin. It's an MIT licensed open source project. We were really inspired when we saw the first demo of Devin. A community formed very quickly in hopes of basically recreating what we saw in that demo, because it was so exciting and so promising for us as engineers to see just how powerful that tool was. Over the last 2 months or so, as we've been building, that vision has deepened a bit. We consider ourselves an open source platform for both building and running software development agents. So basically anything that's interfacing with AI, with LLMs to build software, we want to be able to provide a set of tools that academics and agent builders can leverage in order to see their agents kind of come to life, actually work on software, things like that. And then we also want to provide agent users, so your average software developer who wants to run an autonomous software engineer, the tools that they need to run those agents safely, to understand what they're doing, to have some transparency into what the agent's doing, how it's running, where it might need to be redirected, things like that. So a big emphasis on open. Like I said, this is an MIT licensed project. We're totally community driven right now. Everybody who's working on the project is a volunteer, working out in the open. We have a bunch of academic folks. We have a bunch of average developers like myself, folks who maybe aren't as deeply into the academic side of agent building, but are very interested in software development and application development, as well as just a bunch of end users who may or may not be software engineers themselves, but who are interested in using autonomous software agents to help build software. And all of us are working together really to try and figure out, what is the best end user experience that we can drive for here, and what is the best way we can get there technologically. And all of us really have this goal of making the development of software a more creative, engaging task. Today there's a lot of just slog involved in getting something done when writing software, and being able to push away all the parts that are kind of annoying and rote to an autonomous engineer, and really be able to focus as humans on the creative part of the task, on what does the end user want, what do I want this software to be like and do. If I can focus on that aspect of things, that makes the job of writing software a lot more fun. So that's really what we're aiming for. And again, we want to do this all in the open. We believe that software development is generally lends itself to being done in the open and in an open source way. And so we're very excited about the open source community here. Just some kind of quick stats on the project. We're very early on. We're only about 2 months old. We already have 116 unique contributors to the project. We've merged over 700 PRs. We have over 24,000 stars on GitHub. This is a huge amount of progress for an open source project that's this young. Even beyond these numbers, just the quality of the application that we've been able to build, and the quality of the agent that we have running in there, which we'll talk a little bit about later on, thanks to some academic contributions, have really blown me away. I would not have expected to see an open source project be able to move this quickly and build this much. And it's been really, really impressive to see and really exciting to just be a part of. Cool. So, why are we building this? Can't ChatGPT already write code? Isn't this already possible? And that's definitely true. ChatGPT can write bits of code. It can even, inside of ChatGPT, it can run them to check them. There's a pretty good ChatGPT is actually exceptionally good, as well as the other large LLMs are exceptionally good at writing code. We also have GitHub Copilot, which hopefully y'all are familiar with. This is probably, within my workflow, the thing that has given me the biggest productivity boost is having this LLM-driven code completion right there at my fingertips inside of my development workflow. I absolutely love Copilot. It's a huge kind of design inspiration for our long-term vision around OpenDevin. This idea of something that really integrates directly into the developer's workflow in a way that's invisible when it's not necessary, but is always kind of there when you need it, when it can be helpful. And it's just, you hit the tab key and, you're just moving that much faster. I'm a huge fan of Copilot. But ChatGPT and, just a raw LLM and Copilot, they don't really, satisfy every need here. There's some stuff that agents can do, which make this much better. So agents play nicely with existing code bases. The tough thing about, say, working with, if you're just like working directly inside of ChatGPT, it's really great at writing greenfield code. If you're just like, hey, I need an algorithm that does X, it'll write that function for you. But if you're like, hey, I have this 100,000 line code base and I need you to find the right file to edit within that code base, it's not really capable of doing that. You can't really just like dump your whole code base into the context window and have it try and pick out the right spot. It's probably too big of a code base for that context window. And it's going to cost you a lot of money to do that. Agents can also embed directly into the developer workflow, kind of similar to what we saw with Copilot. I don't know if you all have had this experience, but very frequently I have, when writing code, I will drop into ChatGPT to try and write some function. And then I copy the contents out of ChatGPT and into my code editor, and then I run it, and then I paste an error message back into ChatGPT, and there's this like really annoying copy paste going back and forth. And with an agent, it can really just embed into your existing system. It can write code directly to your file system. It can run the tests for you. So it's a really neat way to kind of embed into the developer loop. It can run in this debug fix loop, which is something that like Copilot doesn't really do well. Right, it can edit the code, it can run tests, it can run the code itself to see what the result is, notice any problems and then fix itself. And really, it works like a human engineer. It can have access to a web browser to look at documentation. It's instead of doing this like kind of step-by-step process that you might do with ChatGPT, where you're picking off these small little bite-sized tasks, you can feed an agent a very large unbounded task, and it can break it down into manageable steps and make several back and forth trips to the large language model to achieve those more bite-sized tasks. So overall, how do agents work? I see them as kind of a hub between several different data sources and interaction points. So at the top here, you have the user who's ultimately driving the agent, deciding what do I want this agent to work on, and so they'll send the agent a task like please fix the tests in my code base, please add this new feature, whatever it is. The agent can also pull in external data, so that might be code from your code base. It might be data from an external like knowledge base, something like that. It could be external documentation, like the API docs for a particular API that's out. It has access to a large language model, and this is really the core. It's kind of like the CPU for the agent, right? It's what's kind of driving the atomic instructions that the agent, the atomic operations the agent is taking, all goes through the LLM. And then it has access to some kind of runtime, right? It has access to a web browser, to a command line, to a file system, where it can actually do the things that the LLM is telling it to do. Here's kind of some pseudocode for what this loop looks like. So it's basically a loop that's built on top of the LLM. So basically, we take the current state of things, which at the outset is probably just whatever the prompt the user gave. We send some kind of prompt to the LLM, and this is kind of where the core specifics of a particular agent live is within this. How do we generate this prompt? We take the response from the LLM and come up with some action to take. We take that action in the runtime somehow and come up with an observation. So that might be the contents of a file. That might be the HTML output or a screenshot of a web page. It might be the result of running a command on the command line. And then we update our state with that observation. So we basically add the output of that command or the contents of that file to the state. And then we loop back to the beginning. We generate a new prompt to send to the LLM, given the output of that most recent command or the results of that most recent action. And the LLM can take one step forward to generate a new action. At the end of the day, it's really about context window management, right? So the LLM has basically no long-term memory. It knows exactly what you're putting into the context window right now. It has its world knowledge that it's learned in training, and it has to use those two things to figure out how to advance one step forward towards our goal. And so you, as the agent builder, basically need to figure out, how do I intelligently, based on what the LLM has done so far, or what the agent has done so far, and based on what I know about the code base, what I know about the user's intention, what do I stick into the context window to move one step closer towards the goal? That could be code, it could be command output, it could be a history of the actions that the agent has taken, it could be a working plan that the agent came up with at the beginning of the process. It could be any number of things that you pull into that context window. And this is really where all the work in designing an agent goes into is, at each turn of that loop, what am I going to stick into the context window for the LLM in order to drive things forward one step? To kind of help with this, building agents and help with this loop, what we've done is we've tried to abstract away as much of this as possible into a framework that we call micro agents. Our best agents are not micro agents. To be clear, our best agents are written in Python. They involve some complex logic for moving from state to state as they progress towards their task. But micro agents are a very powerful way to take on nice little bite-sized tasks in a way that kind of drives that loop that we just talked about of make a prompt, take an action, and then make a new prompt. And so you can see here, this is a micro agent that is actually part of the OpenDevin system today for generating a good commit message based on what's in the Git staging area. So you can see we have this long kind of prompt telling the agent, what its job is. It's a software engineer. Its goal is to write a good commit message. Here's how it's going to find the code changes to describe. And then you can see we've templated out a bunch of kind of the boilerplate that goes into creating an agent. So at each turn of the cycle, the agent is going to get some instructions on, what its history is, how to interpret this history JSON that it's going to get. And it's going to get a history of the last 10 things that it's done, as well as the observations of those things. So that might be, it ran git diff, and this was the result of the git diff command. It opened up a particular file to read the contents, and this is what it saw inside that file. So it's going to see, step by step, what are the last 10 things that it's done. And then it has 3 actions that are available to it. It can run commands. It can reject the task and say, there's nothing in the Git staging area, or there's, I'm not in a Git repo, I can't do this. Or it can finish and say, here's what the commit message is. And then it gets some instructions on basically telling it you have to respond to JSON format. The JSON has to be in this structure. It has to represent an action. And so basically, these templates take care of a lot of kind of the boilerplate of writing an agent. And this prompt will run in a loop against the LLM in order to drive towards this task of creating a commit message. Cool. So once you've gotten an agent built, a really good question is, how good is that agent? So a lot of work has been done in academia to measure agent quality. Basically, how well does an agent solve tasks related to software engineering? The biggest benchmark here is called SweBench. It came out of Princeton, and it basically tests the ability of an agent to solve real-world issues on GitHub. So these folks pulled over 2,000 issue PR pairs from popular Python repositories. And basically what they did was they looked for PRs where the PR added unit tests and added some code changes to address a particular issue that was available on the repo. And so this makes it really easy to verify that the agent is doing the right thing. Basically, you clone the repo at the place where it was before the issue was fixed. You add the unit tests that were added within that PR. You run the test once, they fail predictably. And then you tell the agent, hey, go and address the issue as it's written from GitHub. Like that's the prompt that's fed to the agent. And then the agent is allowed to do its thing. It's allowed to edit code. It's allowed to browse the web, et cetera. It makes a set of changes. We apply those changes to the repo. We run the tests to see if they pass. And if they pass, you get a thumbs up. If they don't pass, you get a thumbs down. And what we see is that to continue forward a little bit there, the SweBench folks also released a subset of those issues of 300 issues that are a little bit more self-contained, a little bit easier for agents to tackle. It's a bit smaller of a set. This is actually a very expensive evaluation to run on, say, GPT-4. Costs several $1,000s, roughly speaking, depending on your agent and how it behaves to run a full evaluation. So SweBench Lite for our evals has cost roughly $500, $600 to run. So we've been running SweBench Lite to test our agents. And roughly what you see is that state-of-the-art agents right now score around 15 to 20% on the SweBench Lite benchmark, meaning they can fix about 15 to 20% of reasonably scoped issues that have been found on GitHub. So there's a ton of headroom here, right? These agents are still failing at most issues, but it's also pretty impressive that they're able to, for roughly a fifth of issues, a sixth of issues, they're able to get to a solution. And if you think about, if any of you manage a code base or an open source project, being able to just automatically tackle 20% of your issues would be a huge step forward. So we're super excited about the progress here. And we actually just announced 2 days ago, our latest score on SweBench Lite is 21%. And that's a step up of 3 percentage points, or roughly I think 17% in absolute terms over the next best agent from academia. So really, really quick movement here. It's only in the last few months that these scores have started being posted. So we're super excited about our progress and about the progress of the technology as a whole. But again, there's a lot of room for us to grow, a lot of room for these agents to get better, and they're getting better every day. Cool. So in terms of working with agents, for those of you who have seen the Devin demo, this user interface will look somewhat familiar. This is a snapshot of the OpenDevin interface. You can see, it has a main chat window where you can interact with the agent, tell it what to do. It can ask for feedback. It can stop and ask for further instructions, for the directions. It can check in and say hey, am I going in the right direction? Or do you want me to shift gears? And so you can kind of interact with the agent there. It has access to a terminal where it can run commands. It has access to a code editor where you can see all the files that are currently in its workspace, and it can read and write to different files, and you can watch it as it's writing those files. It has access to a web browser where it can browse the internet. We've actually recently added a Jupyter notebook where the agent can, if you have a task that's a little bit more oriented towards I'm just trying to analyze some data right now, you can work with it inside of a Jupyter notebook. So it's really, kind of a pair programming environment with the agent. But this isn't the only way we see folks interacting with agents. Personally, I'm looking for an agent that can integrate much more directly into my development loop. I don't really want to, leave my Vim environment and go into a web browser and interact with an agent there, and then drop back to Vim once I'm done with the web browser. I want something that's a little bit more Copilot, which can come with me, as I edit code, help me make edits, help me run tests in the background, help suggest paths forward, things like that. And so, we're really trying, again, to build an open platform where we can drive not just a web experience like the one we saw in the previous slide, but where we can drive VS Code plugins, Vim plugins, where we can interact directly inside of GitHub, where you could just tag an issue and OpenDevin could go and fix it, where you could leave comments on a PR and OpenDevin could address those comments for you. Where you can interact with it on the command line or within a CI/CD environment. Really, we want agents to be able to interact with your code base anywhere a software engineer would. They should really be like a remote teammate who's collaborating with you. Cool. And now I have a demo to share. We're going to hope the demo goes smoothly. I already know for a fact that I have ruined the file system permissions on my current system because I'm trying to debug an issue with users who are running Devin as root. So we're going to see it fail when it tries to edit an existing file. But first, we'll start with a simple task, kind of my favorite, hello world task, right? A bash script that prints hello. And you can see as it's going about its work, it'll kind of describe what it's doing. You can see it running these commands as they go. Should see hello.sh pops up here. Pretty straightforward, right? It just wrote a brand new bash script. I can also, ask it to make edits. So I can say add a command line arg for the user's name. And so you can do this kind of iterative development where it achieves some task, and you can say, okay, now I have some extra requirement that I want to add to this. And so you can see it edited the script to add hello one. Let's test it with the name Jerry. So we can see it, it can run it, test it, things like that. But writing a hello world script, not the most exciting thing. What I really want to show you all is so what I'm going to do is attach OpenDevin not to an empty staging area, an empty workspace, but I'm going to attach it to the OpenDevin code base itself. And I'll actually show you all what I've done here. So I just changed the name of an argument within the OpenDevin code base from -n to -x. And that's going to basically break this arg parser test. It's going to say, it's expecting it to be -n. So what I'm going to do is tell OpenDevin to work inside of this code base. Basically, you just have to, as you start the app, point it to whichever folder you want it to work in. So I'm going to restart the browser, share my screen again. Cool. So you can see, now we're inside of the OpenDevin code base. I should be able to see. Let's see if I can find my way around here. OpenDevin core config.py. This is the file that I've edited with a problem. I added this -x to be a -n. And I'm going to say change the code so that what was the name of my test? This one. So that arg parser test passes. And now, so, by default, the agent doesn't know anything about this code base. So it's going to start by saying, okay, you gave me a file name. I'm going to look at that file. So it's opened it to see the contents. You can see it, digging through it on the command line here. Our core agent, the Kodak agent, which is the one that recently set a new record on the SweBench score, the SweBench Lite score. It does a lot of really creative stuff to be able to navigate through file contents bits at a time instead of dumping whole file contents into the context window. That's one of the things that makes it extremely powerful, is that it can kind of scroll through line by line and see what's up. It looks like it is now trying to set up its environment to make sure that it can actually run the code here. This might take a little while. I think it's trying to install all the packages one by one. Okay,
And
here it goes.
Just
so
a question, like the human can actually just message stuff in the middle, right?
Correct. We're working on getting that working a little bit more strongly. So you can see, like right now, the agent. So the agent has said, okay, I've identified the issue. The command line arguments was changed from -x to -n, and it's saying, it's asking me to actually scroll for it. That's interesting. That's the correct diagnosis. Please fix it. See what it does. So it will occasionally just stop and say, hey, like here's where I'm going. Please, check my thinking. Let me know if I'm going in the right direction. But there should be this ability to like interrupt it and say like, hey, maybe you should, instead of installing these packages one by one, just run, poetry install, and it'll figure everything out.
I think one of the questions from the audience was, do you have some guardrails to prevent it from doing like RM-RF? Yeah,
so that's a really great question. And that's one of the big pieces of kind of our core platform here, is that everything runs inside of a sandbox. It's extremely difficult to get things working properly if the agent is working inside of a sandbox that's outside of your developer environment. You need to make sure that, as I was mentioning earlier, file permissions right now on my file system are all screwed up, because it's very difficult to make sure that the edits that are being made in the sandbox are run with the same user ID that your user ID is. And it takes a lot of plumbing to make sure that everything's correct. Yeah, that's a big piece of the investment we've made into making sure that the agent is able to run things safely. And it's actually, I think it just, I show you my console here, it just hit my file permission issue. Yeah, you can see it's trying to edit the file, but I have permission screwed up, so it can't. So it's just stuck here. But I'll stop the demo there. Of course, the demo gods never fully cooperate, but.
Yeah, this is great. Yeah, it's a super cool demo. It seems like the UI is really coming together as well. And so that you really have a lot of the core components, like the chat interface, like the browser, like the terminal, and actually being able to stream the responses as it outputs. So that's super exciting. I want to go through some of the questions from the audience, but maybe the first thing I want to ask, because I think some of the questions also touch on this, is could you actually give an overview of the current agent architecture / if you can, like some examples of the micro agents? So for instance, I know you mentioned like Kodak as one of the agent loops. If you could even just like explain at a high level, like what it's doing, maybe like why it's good, that type of thing. And then maybe like show some examples of like the micro agent prompts. I think that'd be really helpful for the audience.
Yeah. So we have at kind of the lowest level, we have this agent abstraction, which basically says that it's a very small footprint. It basically says at each point in time, we're going to pass in a state that has a history of all the interactions that have been done. Basically everything that's happened that the agent might want to know about is in that state. And it's going to take one step forward, generally make one call to an LLM in the step. And that step returns an action, which is one of about a dozen different actions that are built into the system that are things like run a command, read a file, write a file, browse the web, send a message, that sort of thing. So, it's a very tightly constrained action space. And then, a very kind of broad state that gets passed into the agent. And then kind of under the hood, the agent is, can do whatever it wants with that state. And basically to construct a prompt to the LLM. But typically what you'll see is it puts in a history of interactions. It might highlight any the most recent interactions, and then it might like say, okay, the last thing you did was run a command, maybe analyze the output and send a message about what you think happened there and what your next step should be. So that's kind of the rough loop that every agent follows. The idea behind micro agents is to really abstract away even more of that process. So instead of managing state at every turn of the loop, and instead of like writing Python code to decide what goes into the prompt and like constructing this big prompt string by hand, all you have to do to write a micro agent is write some markdown with some template strings for like where the history should go, what kind of actions the agent should be trying to run, that sort of thing. And I can share my screen and kind of show what a few of those micro agents are looking like. They're very,
Yeah, sure.
we're really looking for contributions here. What I am hoping for is a library of like hundreds or thousands of micro agents that we can delegate to for simple tasks like open up a PR on GitHub, write a unit test to address the changes that are in the Git staging area, things like that. So all of our agents are in this agent hub directory inside of the OpenDevin repo. The micro agents all go in this folder. And so like, for instance, we have this math agent that will just like, if there's a bit of math that needs to be done, we're going to figure out, the area of a circle. It will basically write some Python code, run it, and then like stick the answer into the output. We have an agent that like manages Postgres migrations, which I haven't actually used. We just kind of like wrote it as an example. We have an agent that will look through a given GitHub repository and just like investigate, what does this repository do? What is it about? What is the code structure like? And it can pass that on to the next agent that's actually supposed to write code changes. We have an agent that fixes typos in plain text docs like READMEs. We have an agent that like will verify any changes that have been made. So it'll take the original task. It is given a code base where some changes have been made, and it has to like run commands to make sure that those changes are good. It can be kind of as big or as small as you want. And so I'm excited about what the community might be able to do with micro agents and contributing these kind of like bite-sized tasks that agents can take on. And then what's neat is that these tasks can these agents and any agent can, as part of its workflow, it can, one of the big actions that we have that it could take along with reading files, writing files, browsing the web, is delegating to another agent. So it can say, okay, here's a subtask that I want to pass off to the math agent because I need to know, what the result of this, kind of complex math problem is in order to move forward. Or I can delegate out to the Postgres agent to write a Postgres migration for me because it's going to do a better job than the very vanilla Kodak agent can.
So yeah, this is super interesting. So actually, one related to one of the questions I was going to ask is, how are these micro agents invoked from like a higher level agent reasoning loop?
Yeah, so it all goes through that delegate action. I can actually show you. We have this delegator agent that works. It's just Python, and basically what it does is, so you can see here's the step function I was talking about before, where it gets passed in a state and it's going to generate an action. And basically what the delegator agent does is it just decides, okay, what was the last thing I did? If I was currently delegating to the agent that's studying the repo, next thing I'm going to do is delegate over to the agent that writes code. If the last thing I was doing was writing code, then I'm going to delegate over to the agent that does verification. If the last thing I was doing was verifying and the verifier said, yep, you're good, then I'm going to finish. Otherwise, I'm going to kick things back to the coder and I'm going to tell it, hey, here's what's wrong. Here's what the verifier found. And so basically the delegator agent is only delegating out to other agents. And it's basically managing this in a loop, saying, okay, start by studying the repo and then move back and forth between coder and verifier in order to move towards the end goal.
And then, so I'm assuming like the delegator agent can also delegate out to micro agents, or is that handled by one of the sub agents as well?
So this delegator agent is like kind of a demo of the delegation stuff. It could delegate out to any agent hypothetically. The way it's coded right now, it's just got these 3 agents hard coded. I can also show you within the micro agents, there's this manager agent, which is a little bit easier to read in raw format. But it's given the delegate action as one of the actions that it can take. And we say, hey, here's the list of all the agents that are in the OpenDevin system that you might want to delegate out to. And we describe each one. This isn't something that's like working super well today. That's just like a lot of random agents all kind of strewn together. We could definitely do a much better job of kind of guiding it towards which agent is good for which task. I think it's basically just guessing based on the name of the agent right now. But this is kind of how that would look like is, you give it a list of agents and say, here's everybody you have access to. Who do you want to delegate to next?
And the last kind of question along this topic, which is an audience question, is so when you think about like agent orchestration, so you have like a delegator agent and sub agents and coordination between them. Do you think about it more as like let the agent figure out like how to orchestrate between the sub agents, or do you explicitly define flows yourself as like a programmer? Like, do you kind of hard code like, okay, it must go through this and then this, or do you just let agents figure that out dynamically?
What's cool about the system is that it allows you to kind of work through both workflows. So right now, I actually have a PR open to create an agent that will take whatever changes are staged right now and open up a GitHub PR. So it's a micro agent, and it's a very like hard coded workflow. It's like add whatever file changes are there right now. That's just like a hard coded command, and then it has a sub agent for come up with a good commit message, come up with a good branch name, figure out where the upstream repo is and where the fork repo is, or if you should be pushing to the directly to the upstream repo on a branch. And so kind of figures out those pieces dynamically, and then sends a request to the GitHub API in order to open up the PR. And so that's a pretty like hard coded workflow. But as agents get better and better, they should be able to take on a lot more of that without having to hard code everything. The nice thing about hard coding is it gives you a lot of kind of control as a developer over exactly how the agent's going to behave, what it's going to do. It gives you a lot of transparency over like what's going to happen. Leaving things a little bit more open-ended requires a little bit less upfront work and investment. But it leaves things a little bit more open-ended for the agent. It might do something a little bit less predictable. So we really see supporting both workflows as important.
Great. The next question from the audience is, given that the performance on Sweet Bench Flight is 21%, what are some of the main issues that you're seeing, like common sources like hallucinations, common like error modes for OpenDevin? And this relates to the kind of like general topic of just like challenges with the current agent architecture.
Yeah, great question. I would say first off, we're still analyzing our eval results. We haven't gone through all the test cases yet to like figure out, okay, where is it falling down, and kind of like where's the low hanging fruit for us to get the next 5-10 percentage points on the benchmark. But I would say the broad patterns are edits that require like a lot of kind of like meta level knowledge about how the code base works and functions together, right? Like we can, it's very easy to fix a unit test where you're just editing a single function. And kind of like the example I showed earlier, where we have a unit test failing. It just needs to make a one-line edit to an existing function. Like it can find its way around the code base. It can find the right file to edit. It can make the right edits. But something where it's like, hey, we want to add this new feature. It involves like, adding a database migration and then, changing the API to work with the new database structure. and then changing the front end to ingest that new API, like that's a very big, there would be a very common GitHub issue is like, hey, please add a new feature that's going to involve front end work, back end work, database work, and like figuring out how to make those large scale edits across an existing code base. That's really where a lot of the current agents have room for improvement.
Right. The kind of next question is, sorry, I'm trying to find the question. Oh, what's like the minimum compute recommended to run this locally?
So OpenDevin itself does not need much compute, right? It basically runs commands in a Docker file. All the compute is going on, all the heavy compute is going on in the LLM. And
that's for an API.
Yeah, so we use Light LLM, which is a Python library that lets us interface with any LLM through the same function, basically. We can run on OpenAI, we can run on Anthropic's Claude, we can run on any of the Azure LLMs, we can run against Ollama running locally. So we're basically LLM agnostic. What I will say is GPT-4 and Claude far and away work the best. The smaller local LLMs tend to get stuck in loops. They tend to not really make the right changes. The underlying LLM is really the power of that LLM is really what drives the power of the agent. And so we're really only as powerful as the LLM that you're using. So while folks are interested in running locally with Llama 7 billion and stuff like that, it tends to only work for really simple stuff.
One question from my end, actually, you mentioned that one of the kind of challenges of building this is context window management, of figuring out like how to put different things into the prompt. What are the specific components that you're putting into the prompt, and how are you indexing the code base, right? And are you doing retrieval, that type of stuff, to actually return relevant context?
Yeah, that's a great question. So I think the hardest part of the context window management is managing the history of interactions, so the agent can see, here's what I've done up to now, and figure out what's my next step. That works really well up to a point, and then eventually that history gets so long, especially if you're reading the entire contents of files, you end up having to, one thing we've experimented with is kind of progressively summarizing the history. So, as the history gets longer and longer and longer, summarize the first half of the history so that you can cut down on the amount of context you're shoving into that context window, assuming that those early actions are now not super relevant to what the agent is working on now. So that's one bit of context window management that we've worked on. In terms of pulling in code, our initial agent would just dump the entire contents of a file into the context window. If the agent was like, I need to look at foo.py, we just dump foo.py into the context window. And sometimes foo.py is 10,000 lines of code, and you immediately hit the context window limit. So one thing we've done here is the code act agent exposes some functions for searching through code and for looking at files, just chunks at a time, and kind of scrolling up and down inside of that file with these dynamic commands. And that works really, really well for basically grabbing the part of the file that's relevant to what the agent is doing without polluting the context window with a bunch of irrelevant information. So it can search, it can, it can dig through the context window. I think one bit of low-hanging fruit that we have not yet explored is basically ingesting the whole code base into a vector database, which we have been experimenting with LlamaIndex for, in order to do some more dynamic retrieval of relevant snippets of code for the agent to work with.
Yeah, it makes sense. Right now, you're representing it as almost like code search functions that the agent can just call, and it's relatively heuristic based. I'm assuming if you search for things, it would just be keyword search, right? Not vector search. But then if you actually pre-index it with a bunch of vectors, then you can do some semantic similarity lookup.
Yeah, I think we're literally using grep under the hood, so it's exact string,
Yeah, exact string match. Yeah, it makes sense. I mean, grep is a pretty powerful baseline for what it's worth. I was just curious how you were. Yeah. Okay. And so in terms of the like you like in the UX, you mentioned some initial set of like tools. So you have like a code editor as well as a terminal. Of course, like I know the like full Devin app has like web search and potentially like other tools as well. Are there plans to basically kind of expand the capabilities to even solving like more general Sweetbench problems as opposed to like Sweetbench Lite, or just being able to pull in like external information? And if so, like how do you plan to do that?
Yeah, so we have a couple of folks at CMU that are actively working on the browsing functionality. They've done work on browser agents separate from coding agents, and they're very interested in what they can do to push our ability to browse the web, pull in API documentation, et cetera. So we've integrated Browser Gym at this point. Kodak agent is not yet using the browser, which is probably some of the lowest hanging fruit for us to improve the Kodak agent. So we are that's kind of like one of our next steps for pushing Kodak agent forward to solving more of the Sweetbench Lite problem set. We definitely want to get to the fuller Sweetbench problem set, and we also want to do a full Sweetbench eval of OpenDevin today to see how it performs relative to Devin itself, which has published at least a partial Sweetbench score. I think they evaluated on like 25% of the Sweetbench set, and how it compares to other academic agents, like SweetAgent. So that is definitely the goal, is to take on the full, basically be able to solve any issue you find on GitHub, any issue that a software engineer could take on. We want to be able to take on with our automated agents. I think it's probably you're probably going to see years of effort going into that, where you'll see some very quick pace development over the next 6 months or so, and then there's going to be a long tail of really difficult issues. That last 20% of issues will probably take several years to fully take down.
And it seems like you have a few agents in OpenDevin, like you have Codex, you have all these micro agents, you have like browser agents that people are working on. You mentioned the overall goal is to have a platform for AI engineers to just like pull in components to build autonomous software engineers. How, if you're able to like elaborate upon that vision, like what is the unit of abstraction that you expect like a developer to be able to pull in to kind of build something? Is it just like they're able to import an agent from like a suite of different agents that you offer? Is it that you just like they can clone this entire thing and they can just like modify the UX? I'm kind of curious how you're thinking about that.
Yeah, so there's kind of two sides to the platform, right? We want to appeal to folks that are building agents and folks that are kind of at the bleeding edge of what agents can do. And we want to appeal to the end users who are running these agents, right? And so on the first side, what we really want to do is take care of all the nitty-gritty work that goes into building and evaluating agents. So that's like having an opinion on what the agent loop looks like, how actions are structured, things like that. And B, like really providing all the stuff like the Docker sandbox for running commands. So this thing's not going to rm-rf, your root directory, things like that. So providing all that kind of like base infrastructure for running the agents as you're building them and testing them. And then we've also actually packaged up Sweetbench Lite so far, but working on Sweetbench in a very easy to run pipeline. So we want to basically make it easy for anybody who has built an agent to wrap it in our interface, which should be generic enough to handle any agent out there. Wrap it in our interface and very quickly be able to run an eval and see how do you do compared to other folks. And what we'd love is for everybody to kind of consolidate on OpenDevin as a standard for how you write agents, even though under the hood, they could be doing very different things. They could be structured in very different ways, as long as they kind of conform to this very simple interface of like, pass in state, step forward one step, and produce an action at each step. As long as they conform to that interface, they'll be able to plug into all this amazing extra architecture that we've built for running the agents, evaluating the agents, et cetera. And then on the user side, right now, like I said, we have a web interface, but what we're working on now is a re-architecture to enable many different types of interfaces, whether it's a CLI or a VS Code plugin, to interact with these agents and be able to pull in their results and run the actions, things like that.
Yeah, super exciting. Take us through, and just in the last few minutes, like what's coming next? Like what are things that you're excited about? What is like a general landscape of Like, is it just adding more agents, adding better agents, like adding better UXs? Like, what are you excited about in the next few months?
Yeah, I think one of the things that's most exciting right now is just being able to push the agent itself forward. Like I said, we just announced the other day our results on Sweetbench Lite, which were super exciting. Got a bunch of excitement from the community, which is great. And I think we still know of a lot of low-hanging fruit for pushing that agent forward. And so Xing Yao, who's a PhD student at Illinois, is the brains behind the Kodak agent, has published a paper around it. He's going to be working on really pushing that core ability forward further and further. So very excited about that. And then there's also the tailwind of LLMs themselves getting better. When GPT-5 comes out, our technology is going to get that much better because we'll just be able to flip a switch, start using the latest LLM, and the agents will just naturally get better as a result of that. So I'm very excited about where the agents themselves can go. But in addition to that, the thing that I'm most focused on now, while Xing Yao is focused on pushing the agent forward, is I'm focused on building this very more scalable, more generic architecture where we can start interacting with agents in more than just that web interface. It can be on GitHub issues, it can be on the command line, it can be inside your code editor. And so that's what I'm really excited about personally, is really being able to integrate these agents, and especially the Kodak agent, into my personal day-to-day workflow.
Makes a ton of sense. And last question is basically how, we talked about agent orchestration. How do you, you and the other contributors orchestrate amongst yourselves, basically? I mean, is this like a decentralized thing? Do you like meet once a week? And then also, from the audience, like if they're interested in contributing to OpenDevin, like how can you basically become a contributor to OpenDevin?
Yeah. I would say it is pretty decentralized, especially now that we have an evaluation pipeline set up. My hope is that it's basically a little bit of a competition, kind of like, the Hugging Face leaderboard style, right? We can tell who's the best agent. And so if you contribute an agent and you beat Kodak on the Sweetbench Lite score, you'll probably become our new default agent. And we really want to kind of get that friendly competition feeling going. And what's fun is like you could build an agent that delegates 60% of its tasks out to Kodak agent and delegates the other 40% out to a different agent. And as long as you're managing that delegation better than anybody else, you'll do better and you'll become the default agent. And so it is this kind of decentralized, data-driven way of deciding, what is the best agent out there, what is the best architecture out there, et cetera. And yeah, the best way to contribute is to just, open up a pull request, maybe file an issue and let us know what you're thinking about building, what kind of feature you want. We have a ton of open features or open issues that are labeled like good first issue, a ton of, potential feature requests, a ton of requests for, there are a bunch of agents that have been built in academia, a bunch of like interesting agent architectures that are out there that we have open issues to just like, hey, let's build an agent that implements this and see how it does. So there's tons of room for folks to contribute here.
Great. Well, I think that's a great way to conclude this webinar. Thanks so much, Robert, for joining. For those of you who want to check out OpenDevin, please check out the repo, check out the website as well, the docs and the demo, and then we'll have this on YouTube very shortly. So thank you, Robert, again for your time, and thanks for joining.
Thanks so much for having me.